Hello! Today I want to show you a few useful things connected with BGP performance on routeros. If you have no idea what I'm talking about, BGP is a border gateway protocol that exchanges routing and reachability information among autonomous systems. Essentially, it is for ISPs. If you are just getting started, you will need to read our manual for now. Perhaps I might do a beginner BGP video some other time. Let me know in the comments if you would like that. So, today the first thing I want to show is affinity. routeros v7 is capable of splitting tasks between multiple processes. There is one main task, which can start, stop subtasks and process data between those subtasks. Each subtask can allocate private and shared memory. Private is accessible only by this particular task, and shared accessible by all root tasks. BGP receive and send can be split into subtasks by specific parameters. This split by subtasks is controlled with input affinity and output affinity configuration in routing BGP template or in BGP connections. By default, affinity parameter is set to alone. Alone means that input and output of each session are processed in their own processes. Most likely it is the best option when there are many cores and many peers. Maximum 100 processes can be processed at one time. So, if there are, for example, 200 BGP peers, it is too many for alone, and then it is better to split the processes by another parameter. Let's see how it works. Here are 3 BGP peers. All of them receive full BGP tables. I use CCR router with 16 CPU core count. We run command routing stats process print to see memory and process division in time. So I will enable my peers and let's run the command again. Here we can see memory and process division in time, and we see that BGP sessions are processed by different processes here. Also, we can run tool profile and check how long the process on routing has proceeded. Here, when it stops, there will be 0 in the routing. Now let's set affinity to main to run input-output in the main process. It could potentially increase performance on single-core, even possibly on multi-core devices with a small number of cores. We should restart the connections to get the newly applied settings working. Then I will run routing stats process print again. We see that all BGP peers, both output and input, are processed by one main process. If we run tool profile and compare the times it was used for the routes calculation and importing them into routing tables, then we would see that in this specific case, when affinity is set to main, it takes about 30 seconds longer. I use stopwatch to test it. Also, it is possible to set affinity value as FE, instance, VRF, remote AS. In this case, firstly output and input will be divided, and then the processes will be divided by set parameter. For example, if affinity is set to instance, then divided by instance. One more option is to set output affinity value to input, and it means that output will run in the same process as input runs. You can try to set different affinity values on your router and check which parameter fits better in your case. The second thing I want to show is input accept an LRI parameter. It is a quick way to filter incoming updates with specific NLRIs. This abbreviation means Network Layer Reachability Information. It allows filtering incoming messages directly before they are even parsed and stored in memory. This significantly reduces memory usage. Regular input filter chain can only reject prefixes, what means that it will still eat memory and the routes will be visible in routing table as not active filtered. To apply input accept NLRI changes in a session restart is required. Let's leave one BGP peer for this example. Create an address list in IP firewall. Here my address lists. We add this list to input accept NLRI parameter. Then we restart the peer. And let's check the routes. Here we see that only accepted BGP routes are present in routing table. If we will set a regular filter as well, it will proceed after NLRI. I have a filter that will reject one of accepted by NLRI network and accept everything else. I add the filter to the connection. This time no peer restart is required. Then run iproute print, and we can see here that firstly routes were dropped by NLRI, otherwise we would get full BGP table, and only then left routes were preceded by the filter. There are also other input parameters that work similar as NLRI, for example input accept communities and others. You can see them in our manual. The last thing I want to show today is a way to combine routes that are advertised by the router. For example, there are several /24 subnets. I want to advertise them, but I want to combine these several routes into one /21 subnet. I add this network in the firewall address list and select this list as output network in BGP connection. Here. The route from output networks will be advertised if there is an IGP active route to the same network. I mean they must be absolutely same with same subnet mask. So, for IGP active route existence, I create a black hole route to this network in IP routes. Here is this route. Let's run routing BGP advertisement sprint to check if this route is advertised. Yes, it is. When a packet from the other router will come to IP address from this network, it will not be black holed, as the router will select the most specific active route and it will use /24 route from this routing table in this case. That's it. Thank you for watching.